Hey everybody, it's Bob Crossan, Senior Managing Editor for Water and Waste Digest. I'm here with Kunrad Pretorius. He is the Service Line Leader for GHD. I also have Ian Gabriel. He is Resource Recovery Product Leader for Sydney Water. We also have Laura Roth, Senior Process Engineer for GHD, and Luke Justice. He is Process Controller for Sydney Water at the CAME Hub. We're going to be talking a little bit about the Malabar Wastewater Treatment Plant in Sydney, which was featured in an article in our February issue of WWD this year. The article discussed its process reliability and renewal project, so we'll be diving deeper into the goals and reasons behind that project. So thank you all for being on the call with me today. We've got a full room today, so appreciate you all making the time.
No problem.
So first things first, I wanted to get some context that we can work from here. Can we talk a little bit about the treatment plant? What is the service area? How much population does it serve? What are your flow rates, average and peak, all that kind of stuff?
Yeah, I can answer that one, Bob. So Malabar is actually our largest plant. So it services about 2.2 million people, which is getting close to half of Sydney's population. Treats an average dry weather flow of 470 megalitres a day, or that's 124 megagallons per day. And it's designed to receive wet weather flows of up to 1,300 megalitres a day, or 345 million gallons a day. But prior to this project, we had a number of issues, particularly with screenings removal and handling, and with odorous and sticky biosolids. And as you can see in our backgrounds, the plant is quite close to a fairly popular beach and a residential area.
Gotcha. So what were some of the primary goals? So we talked about this process reliability and renewal project here. What were some of the primary goals and why you guys wanted to initiate this project from the get-go?
Yeah, so as I alluded to in the previous answer, it was really commissioned to address reliability issues, a number of asset renewals that required assets getting to the end of their life, and in particular to improve the biosolids product quality, which, as I mentioned, we had issues with odour and also with stickiness, the handling of the product, which was difficult to transport. So I guess some other objectives were around continuing to protect the beach water quality. As I mentioned before, there's a number of popular Sydney beaches nearby. Continue to meet the environment protection licence we have. Improve the safety and working conditions at the plant for our staff. And improve operational conditions and efficiency by providing process capability, reliability, and operability of the equipment on the site.
Mm-hmm. Yeah. How did you guys end up funding this project? I have this written down as something of interest from the article that was published as well.
Yeah, well, Sydney Water funded the project ourselves via our Renewals and Capital Works program. So we're a regulated business, so we have a pricing regulator, and the way they set our pricing and revenue allows for recovery of efficient operating costs and return on any prudent and efficient capital that we spend. So it wasn't any private financing involved; it was fully funded by Sydney Water.
Mm-hmm. Yeah, awesome. Well, that's pretty interesting. So in the article here, there was mention of the importance of solids retention time. Sludge thickening was also a critical piece here. Why were these two things, so the sludge thickening and the solids retention time, why were they such critical parts of this plan and these upgrades that you guys put into play?
So at the time of the upgrade, I believe the digesters were operating at a SRT of around 10 to 12 days. So, it wasn't close to optimal. There was an issue with product quality. The sludge coming out of the digesters at such a low SRT is pretty odorous. Sydney Water has a target of maintaining a SRT above 30 days, which they found to be helpful to reduce odors and improve digested sludge quality. So those are all some of the concerns
Mhm. Yeah. And there were some new mixers that were involved here too. What were some of the considerations that were made in determining the mixers that you went with for this project?
Yeah, so some of the key criteria that we were looking at was around the digester mixing effectiveness, the whole of life cost for the mixers, as well as ensuring that they were compatible with the existing digester roof structures. So one of the first things we actually looked at was whether we could reuse the existing mixing system. So that was a gas lance mixing system. Because we acknowledge that with the PIRE upgrade, the inlet works system would be significantly, the performance and the reliability would be significantly improved, and therefore reduce, the amount of screenings carry over into the digesters, and to some extent the grit as well. So we did look at that, and we had a look at some CFD modelling for those mixers, but what we did found was it wasn't able to achieve sort of the minimum criteria for achieving velocity gradients within the mix, within the digesters. So we then looked at two alternate mixing systems, so a mechanical paddle mixer as well as a pumped mix system, and that was just within those active digesters. We reached out to suppliers, and they were able to verify that the CFD modelling, via CFD modelling, that the digesters were effective in maintaining the sludge and grit in suspension, and achieving a homogeneous mixture. And I guess it really then came down to the whole of life cycle cost. So the install capital costs for those two units were pretty similar, but the operating cost was the key differentiator. The paddle mixing system had a power draw of about 7.5 kilowatts versus the pumped mixing system with the power draw of about 100 kilowatts. So over the life cycle, that meant that you could save around $1.5 million Aussie on operating cost over the life cycle. So I guess the preference then fell with the paddle mixing systems, where it was compatible with the existing digester roof structure. So at Malabar, there were two types. One system does have a floating gas roof, and so for that system, we installed the pumped mixing system. But for two of the other active digesters, it's a floating roof, but it actually floats sort of on corbels on the sludge. So it was appropriate to be able to install the paddle mixers for those digesters, and that's what we did.
Yeah, man, that's
Well,
lots of.
Laura did a nice job of describing, the CFD and the scientific approach to sizing the mixers.
Mhm.
The other thing that I think I'd just like to add is that, with the recuperative thickening, the viscosity increases significantly. And I guess one approach to do that is just to put in a really big mixer and hope for the best. That's obviously not the approach we took. We actually did some extensive testing on the rheological properties of the digester sludge at
Mhm.
different solids concentrations, and use that data to really optimize the design of the mixers, and also the sludge pumps and the heat exchangers. Another little interesting part is that we tested the head loss through the primary sludge pumps, and found that the calculated value was within 1% of what was measured on site. So that really neatly illustrates the benefit of taking the scientific approach.
Mhm. Yeah, I was gonna say it sounded like it was really involved to pick out the perfect thing that you needed to do and make sure that it worked in the perfect way that it needed to work. There's a lot of effort put behind that. What types of lessons did you learn over the course of that process of determining that are you taking into future projects with different projects, maybe not specifically with Malabar, but with other utilities and whatnot?
So I think the approach of actually taking the sludge and actually measuring the rheological properties, that has significant benefits. You can find all sorts of correlations and estimates, but what we're finding is that every site is different.
Mhm.
There's a significant benefit to actually testing what you have at a given site, and making sure you're designing specifically for that.
Mhm. Yeah, for Ian, what did knowing that it was going to be so tailored to you do on in terms of like your work and whatnot? Did that help make sure that what did that feel like to know that you had something that was so tailored to your system?
Oh, I might throw that to Luke. He was probably involved in the more day-to-day of the design process and selection of equipment than I was.
Well, Malabar is a complicated site purely from its history. It's been built in various stages over the last 60 years. So every digester being completely different meant it was challenging, but having these guys here and basically producing a bespoke solution for each digester as it needed it really says a lot of fears that the operators had about the way the upgrade would go. And the final solutions delivered have really increased the quality of life for basically everybody working there day to day, as well as everyone in the neighboring suburb, quite frankly.
Yeah. So I wanted to touch on too the final biosolids quality here. Could you elaborate a little bit on what the final quality was like, and how are those biosolids now being used as well?
So the product quality used to be quite bad, frankly. It was smelly, it was sticky, it was wet, it was hard to transport. The complaints were consistent and numerous from everybody who had to live anywhere near the trucking route. The changes made by the PAR projects actually improved things in 3 ways. First of all, it massively improved the solids content of the cake, the sludge. There's a significant increase of about 5%, which is a huge change in trucking numbers. So normally instead of 140 20-ton trucks in a month, we're down to 100, 110 sort of area. It is also much more solid consistency-wise. So not only is it less to transport, but it's much easier to handle when you do transport it. And the odor is the really big win for us. The odor potential after 3 days of storage has been reduced by about 90% actually. So with Sydney Water's internal grading of biosolids quality, the product is land applied, but it used to have to go really quite far out of Sydney, and it used to have to be reprocessed at a facility prior to being applied to land. And nowadays we can directly apply it to land, and we can do it much closer to the plant, which is great because it's as far east as you can get in Sydney, and all the farmland is as far west as you can get from Sydney.
Yeah. Well, that's awesome.
Yeah,
That's great.
Yeah, so just to add to what Luke said, we have a beneficial reuse program for all of our biosolids across all our plants, and we pride ourselves in beneficially reusing all of our biosolids. But as Luke alluded to, some of them were more challenging to deal with, and Malabar was in that category, and so we had to spend quite a lot of extra money in terms of additional processing and transport costs for that product. Being one of our larger sites, that obviously had an impact on costs. So since the upgrade was completed, we no longer need to reprocess, and it actually saves us around about $750,000 a year, Australian dollars, in terms of those cheaper processing and transport costs compared to what it was like prior to the upgrade.
Yeah. Well, that's excellent results, and obviously falls perfectly into what the purpose of this plan was. So it's really cool to hear how successful it was for you. Anyway, thank you all. I do appreciate you all taking the time today and speaking with me a little bit more about the plant and whatnot. I appreciate your time. And for anybody who's watching, who's interested in learning a little bit more about this, we do have a link to the article in the description of this video below. We will also have some links to some of the Sydney Water resources as well on this facility. So check that out down below. And thanks again, all of you, for being on the call today. We appreciate your time.
Thanks, Bob.
Thanks, Bob.